Okay guys, this time we're looking at the multiplication rule with conditional probability. So the conditional probability would be, let's say I take a marble out and I don't put it back in. Big difference, because as soon as I take that marble out, all the other probabilities now in the bag change. Okay, so I'll give you an example. Well, the probability of me putting in my hand here and taking a blue is 2 out of 2, 8. Okay, because there's 8 altogether. Okay, so 2 blues out of 8. That's fine. What about the probability of me taking a blue and then a red if I put the marble back in place? So this is not conditional probability because I'm putting the marble back in. Well, it'll be, so is it a blue and a red? So a blue is 2 out of 8, and let's say I take the blue out, so get the blue, take it out, but then I put it back in again, and now the probability of getting a red is also 2 out of 8. So 2 out of 8, and remember we multiply because it's a blue and a red, and that will give us 4 out of 64. Okay, right. Fair enough. But now we're looking at conditional probability. This is when I take a ball out and I don't put it back. As soon as I take that ball out, the probabilities will change. Okay, so this time we're going to say the chances of me getting a blue, so getting a blue and a red. However, after I take the blue out, I don't replace it. Okay, so let's go. Well, put in my hand, chances of taking a blue, 2 out of 8. But now that blue is gone. So now I put in my hand and I take a red, and it's 2 out of 7. Okay, so that will give me 4 out of 56. Okay, so you see the way we have to allow for the change, the change in, I suppose, variable really. We have to allow for, after my first pick, I didn't put it back in, so therefore the probability changes. It's not 2 out of 8 anymore, it's 2 out of 7. Okay, so there's conditional probability in, I suppose, a simple enough way, and a lot of this is common sense. Okay, often I would suggest draw it out. If you're asked a question like this, draw it out, it'll make more sense. Okay. Right, this is now a different type of question. We have a Venn diagram, and these are the people who play football. So there's 10 people who play football altogether. 8 people play just football, 2 people play both football and hurling, and there is 8 people who play hurling, but again 2 of them play football and hurling, 6 of them just play hurling, and 4 people who play none. So the universal set, there's 20 people altogether. Okay, let's look at this. Find the probability of choosing a person who plays hurling. Okay, so all these 20 people are there in a line. What's the chances of me choosing a person who plays hurling? Well, the probability of choosing a person who plays hurling will be, there's 8 people who play hurling, 6 just hurling, but there's also another 2 that play both. So it's 8 out of 20, which is 4 out of 10, which is 2 out of 5. Okay. Next one, plays hurling only. Okay, plays hurling only, well that's 6 people out of 20. So 6 out of 20. Okay, and I'm not gonna make that fraction in its simplest form. Plays football or hurling. Okay, now let's think. It's the or rule. Ordinarily we would say, well, 10 people play football, or 8 people play hurling. Okay, so that's what we're saying, plays football or hurling, and or means add. So 10 out of 20, or plus 8 out of 20. However, before we finish this sum, we have to ask ourselves, is this a mutually exclusive event? Mutually exclusive event would look like this, because we can't get both with the same pick. Non-mutually exclusive event, they overlap, because think about it, I can kill two birds with one stone here. I can take one pick and I can get someone who plays hurling and football. So we have to minus this. We have to minus the I suppose the football intersection hurling, which is 2 out of 20. And that will give us 16 out of 20. Okay? And that would make sense because 8 and 2 and 6 is 16. Okay. Right, question 4, guys. I am going to keep that for the last one, okay? That's probably the most difficult one there and the most new material, okay? So we'll keep that. I will do this one though. Plays both, given that the person does play hurling. So get our head around that now. What's the probability of choosing a person who plays both, given that the person does play hurling? So what they're saying is the person we choose, they do play hurling. So it's one of these people. Okay? And they're saying, what's the probability of choosing a person who plays both? So what's the probability of choosing this from the whole lot? Okay. So in this one, there is a bit of a formula, okay? And this is what we'll say. Say the probability of... So there it is, okay? So it's what's the probability of choosing A when B has occurred? So if you look up here, what's the probability of choosing this when this has occurred? Okay, what I mean by occurred is, well, we're definitely choosing someone from here. What's the probability of choosing someone from here when this has actually happened, when we're definitely going to choose someone from here? But common sense, we're even forgetting this, okay? Common sense will tell us, what's the probability of choosing one of these people from the overall amount? Well, that would be 2 out of, and there's 8 altogether here, which equals 1/4. Okay, so common sense would say, well, if I have the 8 people who play hurling, what's the probability of choosing one of these people from that 8? Well, it's 1 1/4. Okay. But I suppose if we want to look at the formula, well, the formula says the probability of A, so the probability of getting A when B has happened is the probability of A intersection B all over the probability of B. Now that makes sense. Let's have a look. The probability of A intersection B. Well, A intersection B is 2. And the probability of B, well, there it is here, is 8. And that's 1/4. Okay? So hopefully that makes sense. Do we have to learn this? Yes, it's not in our logbooks. Common sense, though, will get you a long way in this question, right? But it will be a help to learn this. Okay, last one. A person who plays both. So I'm going to tidy up this a little bit and get rid of some of the work. Okay, so just bear with me a sec. Okay, so we're looking at the probability of getting someone that plays both. Well, there's someone who plays both. So 2 out of, and the overall amount is 20, which is 1/10. So if we have that Venn diagram, it's pretty easy. Yeah, we choose the middle one. But here is the formula associated with that. So if we're looking to get, do it up here, if we're looking to get the probability of A and B. Okay, and what I mean by A and B is the bit here, so it's actually, if you want to say it a different way, A intersection B. And that equals the probability of A multiplied by the probability of B, B given A. Okay, so again, common sense would get us a long way if we have a Venn diagram, but if not, okay, or sometimes this might be handy, okay, if we're asked a certain question, and you'll see later on the type of question you might need it for. Okay, so we know that's the answer, okay, based on our intuition and our common sense. We know that from our diagram, but let's prove it using this. So the probability of getting A and B. And again, this is conditional probability, right? So if it wasn't conditional, we could just multiply the two of them. Right. Well, first of all, the probability of A, which is the football, is 10 out of 20. Multiplied by the probability of B given A. Now, how do I get the probability of B given A? Well, on the last question, probability of A given B, we said, was the probability of A intersection B over the probability of B. So likewise, the probability of B given A will be the probability of B intersection A, which is the exact same as A intersection B, all over the probability of A. So let's find out what that is. Now, probability of B intersection A is the 2 from here, and A then is the football, which is 10, and that will give me 1/5. So putting this back up here, we have 10 over 20, which is the probability of A, this one, multiplied by 1/5, which is the probability of B given A, and that equals 10 over 100, which equals 1/10, and look here, they're the same. So we're after proving we're right based on this, okay? Again, me personally, if you get a question, I would see can you make sense of it using, I suppose, using your common sense. Sometimes you might need to know this, okay? And again, this is not in our logbook, so we do need to know it. Okay? We definitely need to know this. We definitely need to know this. Okay? Okay. Last question, guys. So this is where I would need to use those formulas that I was telling you about. Okay? I don't think our common sense alone will be able to solve this. So two events A and B are such that the probability of A is 0.7, the probability of B is 0.4, and the probability of A given B is 0.03. Okay, I'm going to draw it out first. So they are not mutually exclusive events because of this, and we know, or we've been told anyway, the probability of A is 0.7 and the probability of B is 0.4. But that's the total. That's the whole circle, and the probability of A is the whole circle. So I want to know what the probability of just A is, the probability of A intersection B is, the probability of just B and so on is, and if I get those three, add them up and take it away from one, then I should get the probability that neither occur. Okay, so let's see what I have. Well, I have the probability of A and B, but what do I want? So, well, let's see. I have the probability of A given B. That's 0.3. But I want A intersection B. Now, do I have a formula to give me A intersection B? Not quite, but if we look back here, if we look back to this formula, well, here's the A intersection B. I don't have that, but I do have this, and I do have this. So if I have two things in an equation, I can find the third. So, I want this. So let's set this up. P, so the probability of A given B, equals A intersection B all over probability of B. Put in the probability, okay? Right. So, I don't know what this is. I do know what this, or sorry, I don't know what this is. But I do know what this is, and I do know what this is. So let's fill them in. Probability of A given B is 0.3. Probability of B is 0.4. Probability of A union B, I don't know. But we can find it out. So, quick bit of algebra. I want to get rid of this, so I'm going to multiply by 0.4. If I'm multiplying this side by 0.4, I should be left with A intersection B. And that will give me 0.12 equals A intersection B. Okay, so I can start filling this in now. I know what A intersection B is, 0.12. Now think about this. I know all of A is 0.7, but I have 0.12 of it here, so the leftover bit must be A on its own, and that's 0.58. And likewise over here, we know that all of B is 0.4, but we have 0.12 of it here, so we'll take it away, we get 0.28. Okay, so I'm going to get rid of this now. I have to be mixing, oh, sorry. Not to be double counting. So if I add this, 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 and this up, I should get a probability of 1, because there's no other probabilities, all have to add to 1. For probability certain it's 1. So if I add this, this, and this, and take it away from 1, we can do that. So 0.58 plus 0.12 plus 0.28, that equals 0.98. So it's almost 1. So 1 minus 0.98 equals 0.02. So the chances of actually putting in my hand, and whatever this may be, okay, they don't actually tell us. They don't tell us what event it is or whatever. But I know that if I put my hand in here, the chances of picking something that's not included in A and B is 0.02. Okay. So lastly, the rules to learn. Again, common sense is a huge thing with this. Okay, draw it out, put it into Venn diagrams, it'll make sense. But sometimes we need to know these rules. Okay, they're not in our logbooks. We need to remember. So here's one: the probability of A given B equals probability of A intersection B all over the probability of B. That has to be learned. What that means is, if remember the hurling one, we'll go back here. Okay, so remember that one. What's my chances of picking a hurler? What's my chances of picking a person who plays football and hurling if I know that it's a hurler I'm going to pick? Okay? And the next one then is the probability of getting A and B. Alright, that really means intersection. Well, that is the probability of A multiplied by the probability of B given A. And that is what we've done here, okay? And here. So you might need to go back over this, lads, and go take it slowly through it. We have to learn this and this because it's not in our logbooks, but it is something that's very, very handy if we're given a question like this. Okay? Questions like that, not so much. We can use our common sense. Questions like this, we tend to need the rules. Okay, thanks.